Ladies and gentlemen, good afternoon or good morning, depending where you are on the planet, and welcome to our fifth webinar regarding hydrogen technology and market outlook. It's about time we start. As always, I'm just going to sum up a little bit the rules about this webinar. I'm going to run the presentation about today's topic, and at the end, I will answer all the questions. You have a section directly in the tool Teams to ask all your questions. You can ask your question during the presentation, and we'll take all the questions at the end. In the meantime, two announcements. Our next webinar will be held next month directly on July the 20th, yes, and it will be about oil and gas petrochem market outlook. We have been doing a webinar already at the beginning of the year, and we'll give the update at mid-year with the figures from the first month of the year. So don't miss it. You have the invitation here. You can download also the invitation directly in the discussion field. And anyway, you will, if you participate to this webinar, you will receive an email with the invitation directly. So you will have no chance to miss the information. Also, one announcement. If you would like to see this webinar again or check the video, you can directly follow us on LinkedIn, and you will have some publication with the extract of those videos. Also, if you are interested by receiving the slide from the presentation today, you can shoot me an email at guilhemjean@tobefirstconsulting.com directly, and I will answer you via email, sending you the presentation and the slide. If you have any question, of course, you are welcome to ask us anytime later on. So let's start with the agenda. First, we'll have a small introduction about who we are at To Be First Consulting, and about also our tool project Smart Explorer, which is a project database, including the hydrogen project. And we'll give you just basic rules about it to explain where our data are coming from. Then we'll go more on the topic of hydrogen, why there is a need today, why there is a trend also on the market. We'll talk and go around a little bit all the technology that we see as of today. And then we'll go more on the business side itself with an outlook on today's market. What are the perspectives for the next 5 years? And of course, what are the outlook on the 10-year period and 30-year period, which let's say will go with maturity for the market. So without further introduction, I'm going just to introduce myself and Jean-Charles as well. In fact, we are the two, let's say, people working into Project Smart Explorer database. In fact, Jean-Charles was an engineer working in oil and gas for several years. He was the vice president oil and gas for ABB Group, and he was, let's say, really real experience about the oil and gas market. On my side, I'm an engineer as well, starting in oil and gas, and of course, starting on Siemens side, and I've been working on all the renewable energy, and we have launched several months ago all the parts and Project Smart Explorer about renewable as well. Just to give you an update about our database, Project Smart Explorer, as many of you may know already, our database is covering 1,000 projects globally of the energy market. Main part, let's say, is oil and gas and petrochem, but also renewable. We have around, let's say, more than 250 projects about renewable and decarbonification project. We'll go in more detail about the hydrogen, but you have on the right of this slide the scope we have when we talk about project. So we have all the oil and gas upstream, midstream, all the petrochem, of course, also downstream activities, the chemical industries. And when we talk about energy, we have the electrification, carbon capture, hydrogen, solar, windmill, power generation, and water treatment. If we go in more details about this category energy and what we put under this umbrella, you have a lot of new trends today on the market, like electrification, carbon capture, hydrogen, that we are going to go in more detail right after this slide, but also all the solar, windmill, power generation, and water treatment. And our database gives you all the information about projects happening in those fields. So if you are interested to make business in those fields, of course, you can contact us, and then we can start a partnership. If we focus on the hydrogen itself, what we consider our project today active in the hydrogen business is on one side the hydrogen production. So let's say gray production, blue production, green, waste to hydrogen, and offshore wind to hydrogen project. We'll go in more details about which are what and what is the content of this. Also about the transportation itself, of course, there is a complete value chain. So we have different type of projects like hydrogen terminals, the pipeline, the storage, and also the tankers that are coming on the market as well. Another side of the hydrogen business, which is developing, is also all the ammonia part, because as we will see in the presentation, the ammonia is becoming one of the vectors to transport hydrogen. But we'll go on the technical aspect later on. Starting by hydrogen, I think it's quite important to understand where it's coming from, because let's say 3 years ago, nobody was really talking about it, and now today we see a huge amount of investment going on, and sometimes it's quite tough to understand why and how it works. If we look at the need about this energy transition, we are often, when talking about energy transition, talking about electricity. Now on this slide, what I would like to enlighten is the fact that electricity cannot cover all the oil and gas application. If we look just right on this slide, the oil consumption per sector, you see that a quarter is used by road passenger vehicles. Also, 18% is used by road freight, meaning trucks, most likely, but also buses and stuff like that. You see 6% of the oil worldwide is used for the aviation, for the plane. You have 5% which is used to transport all the ships, and here you have 1% which is transport. 7% of the oil consumption is about steam and heat processes, like you have for cement plant and steel plant, like for example. And you have 12% also of the oil consumption worldwide, which is used for petrochem. What is quite important to understand behind this is that when people try to push in the energy transition that electricity will replace everything, that's true, but only on some fields. For example, electricity might replace the oil for road passenger vehicle, but we know that it doesn't really work for trucks. So those 80% are not replaceable by electricity, and it's impossible to make electrical plane or electrical ships, and it's even impossible to transform the oil and gas application by electricity when we talk about petrochemical feedstock or about steam or process heating. So you see that in the scope of this energy transition, the electricity will of course be a huge vector of energy, but it cannot replace all this application. And that's where, in fact, the hydrogen is needed. Because for many applications, in fact, we could replace the oil and gas by hydrogen. So we see many new applications coming for hydrogen, which are today, let's say, handled by the oil or the gas. So here you have a list of new applications that we hope in the future will be tackled by hydrogen. So we have all the heavy transportation, meaning buses, trucks, planes, ships, and train as well. Some of them might also be electric, that would work, but for many cases, it's supposed to be hydrogen in the future because it's you have a ratio weight to energy which is more efficient. The other application are, of course, industrial heating. You cannot heat cement or steel plant with electricity, so it will consume way too much energy, but you can do it with hydrogen. You also have all the problematic about domestic heating for population, but also energy storage and power storage, which you cannot really do with electricity. And second aspect of the hydrogen is that today, let's say the production of hydrogen is not really clean by itself. So part of this energy transition will be also to clean the hydrogen production to tackle all the applications we have with hydrogen. And most of those applications we have as of today are in refining and chemical processes, and also for ammonia production. And that's where we see this, let's say, need of hydrogen appearing as of today, that the electricity cannot cover the whole scope of the energy transition, and we need the hydrogen as a green fuel to be able to cover other applications that cannot be done by electricity. Now going to the trend itself, I would say it's a little bit an opportunity, and that's why the timing is quite important today to go on hydrogen. Is because as soon as the COVID start to let's say tackle and kill our economies worldwide, governments have launched a huge plan, huge investment of hundreds of billions in economies. And of course, then the question for governments was to say, okay, where are we going to inject this money? And for many investments worldwide, the idea was to say, okay, we have the opportunity to invest huge amount of money. Let's make those investments in energy transition, because that will be our future, of course. And all the, let's say, developed economies are really looking forward to decrease their carbon footprint, and it's quite important to try to save our planet. So the idea behind it and those energy transition projects is to say, okay, we have nitrogen, it's a great energy vector, and it will be useful for us to decarbonize our economy directly. So it's quite important to do this work and to do it quite efficiently as well, so we are sure that we are on time to save the planet. And it has been a huge work for, let's say, all developed economy worldwide to say, okay, how do we do this job? And hydrogen has been a good way to do it. And that's why you see, as of today, a huge investment right on hydrogen itself. Behind those hydrogen trends, of course, you have, let's say, motivation for government to invest in those. The first one, I would say, is the survival aspect. Hydrogen is a huge stream of the energy transition. We will not be able to make our energy transition without hydrogen. So, of course, let's say it's a little bit a survival question to use hydrogen, and we need the hydrogen in our economy if we want to have a long-term perspective on our planet. The second argument and motivation would be for all developed countries, and we know for political reason that energy independence is vital to any developed countries. It's vital for Europe, it's vital for US, but for China and all the countries worldwide. So if they want to be in the future energy independent, they will need to be independent on the hydrogen, and they will need to have their own, let's say, supply chain of hydrogen, and know how to have this strategic, let's say, stream in their economy. And the last, but not the least, motivation is, of course, business. Clean hydrogen technology and supply chain are not mature. They are not creating yet. They are in a way to be created. And of course, every country in the world wants to take, let's say, the leadership on this race to be able to make the best business about it. So it's really a race we are starting to experience today. It's a race to develop the technology, the supply chain, also the infrastructure to distribute the hydrogen that we are going to produce. But okay, it's not only about the supply that we are going to build, because we see in more details how we are going to do it, but also to build the demand. So to build, for example, the vehicles, to build the plane that will run on hydrogen. So we know that even if we have the production, we need also to be able to use this hydrogen. So going to the hydrogen technology by themselves, we'll start just by a small focus on the hydrogen itself. Hydrogen is a green fuel. It really is a green fuel of the future. It has huge strengths because it's abundant worldwide. It's quite easy to produce if we look at what we call the green production method. I mean, you just need electricity and water, and then you can more or less build hydrogen production. So it's quite, let's say, easy to produce. It's also quite stable, meaning that as soon as you have produced your hydrogen, you can store it, come back 1 year later, 2 years later, and you can reuse your hydrogen as it was, and you have no losses of energy, more or less no losses, and you don't need to inject energy to store it. So it's quite stable, and that's why it's like the natural gas, quite easy to use. If we look more on, let's say, the safety question, auto-ignition temperature is comparable to natural gas. So as well, it's not something that is so, let's say, would be so dangerous to handle or to transport, for example, because it's not something that if you eat on the sun, for example, that would just go into fire. So that's something which is manageable, let's say, in an industrial process. Also, the hydrogen has the first, and that's maybe the biggest strength it has, is that it means that it can be cleanly produced, meaning that you can produce hydrogen in some ways and under some condition without producing carbon and CO2, which is, let's say, the main advantage of hydrogen if we compare it to other gases and, of course, natural gas. Then one strength also which will play a major role in its development is that the hydrogen is quite comparable to natural gas in its capacities. So for many actors of the oil and gas industry, it's business as usual, how to handle it, how to display it, and how to build the business about it. Of course, the hydrogen has some weaknesses. Of course, the first one is about safety. When you start to initiate and you have flames, it's even invisible and odorless, so it can be quite dangerous to handle. And the standards behind it to let's say, tackle those problematic of hydrogen fire are quite strict, and that's something to look after. A second weakness is that the hydrogen is the smallest molecule you can find, and of course it means that each time you have a leak, you have a bolt or you have a screw, okay, it's the smallest hole can make a leak of hydrogen, and it's quite dangerous. But there are many solutions on the market already. Some of the two other weaknesses are, of course, today a limited clean production capacity. If we look at the production of hydrogen today, 90% of it is done by cracking methane, which is producing a huge amount of CO2 and which is not sustainable for energy transition. The last weakness, and that's already to give you just a ratio and a figure about it, that the energy density you have in volume of hydrogen is 3 times smaller than the same volume of natural gas, which means that if you want to convert, for example, a steel mill from natural gas to hydrogen, it means that you will have to inject 3 times the weight of hydrogen that you were injecting in natural gas. So it means that you need a huge volume of production to be able to replace natural gas with hydrogen. As simple as that. Now, if we look at the different type of hydrogen production, you may know already them, but I would just go through them quite quickly. If you have any question, of course, you can ask me the slide and you will have all the detail about it. All the production of hydrogen is categorized by colors. The first color is gray. That's what we use today. We crack natural gas with steam to produce hydrogen. The advantage is that you have large capacities of production. It's a really efficient process. The disadvantage is that you have high CO2 emission, which are not, let's say, tolerable today. So the gray production is quite close to the brown production. The brown production is not cracking natural gas, but cracking coal. So you can understand that it's even worse in CO2 emission, but again, for countries who have coal, it's really efficient, it's really convenient method. So those two are, let's say, the main driver and the main production tools we have today. And of course, an update or, let's say, revamping of those technology will be what we call the blue hydrogen. The blue hydrogen is either gray or brown, and over which you put a carbon capture unit, meaning that you are going to crack gas or coal to produce hydrogen, but you will not release all your CO2 emission directly in the air. You will put a carbon capture unit at, let's say, the output of your factory, of your plant, and this will allow you to produce large capacities of hydrogen and without, let's say, letting CO2 go into the atmosphere. Of course, as soon as you capture the CO2, you need to transport it and store it under offshore, for example, in aquifers and stuff like that. So you need really to build this value chain to be able to carbon capture, but also to store it. The advantage is that you can keep your existing plant and just make a revamp with this carbon capture, and you have a clean hydrogen. The new technology which is coming really on the market and we are talking a lot about today is the green hydrogen, which is producing hydrogen from the electrolysis of water, meaning that you are going to inject electricity into water and you are going to split the water into, on one side, hydrogen and the other one, oxygen. It's quite convenient because it's a zero emission process. If the electricity that you are using is clean by itself, that's let's say a mandatory condition for it. But he has some downside, and that's why we are, let's say, expecting a huge ramp up in the next years. That today the capacity of electrolyzer are quite limited. It's quite small to build an entire value chain. Also, it needs a lot of water treatment because you need almost pure water to be able to do it. But okay, we'll see in more details how we see the evolution, this evolution behind it. Just two other aspects that I'm not going to go in more details, but sometimes you can hear about the yellow hydrogen, sorry, which is the green hydrogen, meaning that you are splitting the water by electrolysis. It's just that the electricity is not sourced from renewable energy, it's sourced from nuclear energy. So that's one of the, let's say, little, let's say, difference people are making sometimes about hydrogen. And a new technology which is coming on the market today to make project of hydrogen. It has no color yet, so if someone has an idea to how to name it and give a color to it, you are pleased to do it in the comment of the webinar. But the technology behind is to transform waste into hydrogen. So how you do that, I will not go in all the details, but the idea is to use wastes that you cannot recycle, like plastic and stuff like that, to heat them at around 4,000 degrees Celsius. And at this temperature, with pouring pure oxygen into the fire, you have a combination of molecules which is producing on one side CO2 and on the other one hydrogen. And the idea is to capture the CO2 and to use this hydrogen for clean processes. And of course, we have few projects which are currently in demonstrator mode, but we expect to see them develop also in the future. No, just to focus about green hydrogen, because that will be normally tomorrow the biggest, let's say, technique to produce hydrogen worldwide, and with a focus on the electrolyzers. Why talking about electrolyzers? Because that's, let's say, the critical equipment in any green hydrogen plant as we have of today. And of course, it's a limitation factor we have for those plants in terms of production size. So we have three main technology behind those electrolyzer. You have here the detail. You have the solid oxide electrolyzer, the polymer electrolyte membrane. You have the alkaline water electrolysis. You see that they have different capacities each and different ways of working. The idea is just to give you the name because you have the first two, the solid oxide and the membrane, which are really the two technology, let's say, dominating the market as of today, and receiving a lot of investment to develop their capacities. And let's say they are on the way to do it. Not just to give you some figures about the capacities. Today, let's say the largest electrolyzers have a capacity of around 10 megawatts, which is quite small when you know, let's say, the global outlook of energy. And tomorrow, on let's say the vision 2030, we would need electrolyzers that will have 50 times more capacities to be able to build an entire supply chain about green hydrogen. We are going there, but of course, it will take time to ramp up those capacities. The second part about electrolyzers is that if you want your electrolyzers to split water in an efficient way, you need huge volume of water, and you need this water to be of high level of purity, almost pure. And of course, it means that as soon as you have a green hydrogen plant, right beforehand, you have a water treatment or water desalination plant to be able to supply clean water and pure water to your electrolyzer. Electrolyzers cannot work with non-pure water because you will just destroy the equipment. So it means that each time you have a green hydrogen plant, you have this water technology needed right before that. Now, if we leave the production side and we go to the hydrogen transportation, you have three ways today, let's say, to transport hydrogen in terms of mean to transport it. You have the truck, which is already used in many industrial area. It's quite small, it's convenient for small and medium volume. In local area, you can do it very well. You have many trucks who can do it already. It's not dangerous, not too much, let's say. It's flexible, it's cheap, and of course, I will carry on in the future. We'll see a development of this, let's say, transport by truck. Then the second technique is the pipeline. Many pipelines are already existing in industrial complexes, belong most of the time to companies like Air Product or Air Liquide, which are supplying their client directly on local area. but people are starting to believe that we could use pipeline of natural gas to mix natural gas with hydrogen and to distribute both for domestic heating, for example. There are also type of pipeline which are currently, let's say, under the phase of feasibility study to say, okay, we are going to transport hydrogen like we are transporting natural gas over a long, let's say, distance using pipeline over countries, over continent, or below the sea. And that's a study to make because, of course, as the molecule is so small, you need pipeline which are really thick to be able to handle this gas. The last part, but which is not the least, is of course the ship. Ship will be used for the export of hydrogen because we believe that there will be, let's say, a global market for hydrogen as we have of today for gas and natural gas. And of course, ships will be, let's say, a good vector to transport huge volume of hydrogen at low cost because it offered flexibility, delivery, you can go anywhere with your ship, and you have many independent actors which are already looking at this field, and you have the first tanker of hydrogen which are going to be built and delivered during the summer. So it's growing, and let's say all the value chain is coming up to let's say be ready in the next 2, 3, 4, 5 years. Just another, let's say, angle over this hydrogen transportation topic. It's more about the chemical state that you can do it. Of course, you can transport hydrogen into its gaseous state. It's quite simple to store. It's super stable. But the problem is that it's quite inefficient, even at high pressure, because let's say the energy density of hydrogen is really low. So it means that you need to inject, and even if you have huge volume, let's say transported at high pressure, it means that your volume of energy and your quantity of energy will be limited. So gaseous, I would say for local application is great, or for pipeline is great, but if we are talking about ships or trucks, sometimes people try to prefer to go to liquid hydrogen. Liquid hydrogen is great because you have a huge volume reduction, which means that you can really start to be at really a high level of energy density. The problem is that to be liquid, the hydrogen needs to be at minus 253 degrees Celsius, which is right above the absolute zero, and start to be quite cryogenic. And in that the equipment required and the energy required to keep those temperature and to handle the liquid hydrogen at this temperature is quite enormous, and it's quite problematic. The good part is that you can transport huge volume of energy quite easily, also with the right equipment, because some equipment already exists to do those. You can, let's say, transport hydrogen on long period and long distance quite easily. The last vector, which might not be the, let's say, the more natural one, but the one with the biggest, let's say, future prospect is, to me, ammonia. The idea behind ammonia is to say, okay, we are going to produce hydrogen, then we are going to convert hydrogen to ammonia, and ammonia has the different advantages. The first one is to have a high density of energy. You can also use your ammonia as a fuel itself. You can store it in this liquid format as, let's say, room temperature. So it means that, for example, if you are starting to produce huge volume of hydrogen and you want to export it, you can transform your hydrogen back to ammonia, store it in chips, export it, and then you reuse terminals to transform again your ammonia back to hydrogen. And this, even if you have those two operations of, let's say, combination to produce ammonia and back to hydrogen, start to be economically viable when you need to transport your hydrogen on distance over 1,500 kilometers. So that's really today the benchmark to say, okay, what is worth transforming back to ammonia or not? Today, this is the limit. In the next years, that will go down, and most of the transport by ship will be done directly via ammonia. Now going to the business side, of course, that's what really matters at the end. We are going to tackle this problematic on two ways. We are going to see what is the business today. And here I took a screenshot from our database, Project Smart Explorer, where you have in green dots all the projects we have worldwide for hydrogen. So you see that on the map, those projects are quite located in few areas which are really dynamic about hydrogen. You have most of the project and the huge program in Europe. I would say that's where really the let's say the biggest effort is made today to develop this business and this supply chain. Of course, it's well supported by the European Union program 2030 horizon to develop hydrogen, and there are billions of financial public subsidies to push for those projects. But nevertheless, you have other regions where it's also happening. We see many projects happening in Australia with huge volume in the target. We also have projects in Asia, mostly China, and also few in the United States. And in the last month, we saw also Middle East coming quite strong on the market to say, okay, there is maybe an opportunity to, let's say, prepare the future of energy, because as of today, Middle East is, let's say, the energy region for the whole world. But when we will convert from oil and gas to hydrogen, they want to keep, let's say, this role and this job to supply the world with energy. And if they can do it via hydrogen, they want to be prepared to do it. So that here you see in a glance where it's moving, where it's not, and where you place. You see there are a few regions which are acting quite strongly today. And of course, that's the right timing to move and to check what is next to you and to go on those projects. So if we talk about project, just to give you some insights about them, most of the projects we see as of today are, let's say, most small scale, meaning that the capacity of the electrolyzers, most of them are green hydrogen, of course. Sorry not to have mentioned it, but most of the projects we see today are green hydrogen. We see few revamps also to pass gray hydrogen plant to blue hydrogen plant with this carbon capture unit. But most of the projects are green with a capacity to 10 to 20 megawatt, which means that they are quite small in phase. But the idea is to really make the pilot and the demonstrator about those technology, and they have already planned for second phase huge development to go into, let's say, worldwide or industrial volumes. The idea with those pilot and demonstrator is to start producing in 2-3 years, try to accumulate some experience about those technology, to have a feedback and a return on experience about the technology and the equipment to use, and of course to start with larger project later on, let's say, the perspective 2025, 2026. Then we also have in the database few large projects with, let's say, an export vision, mostly in Australia, for example, where here the capacity to be targeted is around the gigawatt. And here is just a huge volume of investment, huge volume of equipment, of course, that will be required. And those projects are targeting to be ready in a timeline of 5 to 6 years, which means that the right time, if you are building equipment for those, is right now. Of course, we have many projects of hydrogen, and for the smaller one, which are coupled with solar or windmill project. The idea behind is to say, okay, to, let's say, give a value to hydrogen, to couple both technology to be able to supply electricity, clean electricity, but also clean hydrogen. All those projects worldwide are all benefiting more or less, let's say, to public financial support. Today, those projects are not viable economically, and they are all benefiting from public subsidies to be done. That's the same, let's say, goal everywhere. The idea is really to be the first to develop this technology. Of course, all those projects today are critical to develop the technology, and the first one to be able to develop the technology will be the winner of this market. Just to give a figure, we have 105 active projects of hydrogen in Project Smart Explorer, and honestly, I think every week we are adding between 2 and 3 projects, so that's really to give you, let's say, the dynamic about hydrogen today. In all the renewable field, hydrogen is by far the fastest growing market compared to solar or to windmill, for example. Now, if we try to put, let's say, a scale to this project and to this investment, here you have the forecast we have for hydrogen. We start really to focus and trace those projects last year, so in 2020, and you see here the business that we have already in 2021, and here you have the forecast we have on the next years. So you can see that the dynamic is really going to the roof with just let's say not a doubling, but 50% increase year to year. And if here it's starting to go down, it's not because the market will go down, it just reflects the perspectives we have as of today on the project, on the future. And of course, the project that will be starting to run and be invested in 2025 have not been announced yet, and we'll have to wait. But we can easily make the forecast that this curve will be carried on the future. So this is the forecast we have in the database. If we look at what has been already awarded, so not forecast anymore, but actual business which has been signed, you see that the year 2021 has already awarded as much or even more business than last year. And you see that 2022 is already above 2021. So it means that you see those investments are already signed, they are already decided, money is on the table, money is working, companies are working on it. And you see that on the next 5 years, we are really starting to get this curve. So that's why we are quite confident about our forecast. We see that the business sign is going on the same trajectory as we are forecasting. Now, if we look at the operator behind those, let's say those projects, here we split it by 3 categories. IOC are international oil companies. That's where you find Total Energies, BP, where you have Shell, Chevron, Exxon, all those big boys. So today they represent 9% of those projects. What we have under NOCs is nationally owned companies. That's where you have all the national companies, for example, in Middle East belonging to the government, or you have also in Asia. And those players on the market represent 30% of the market and of the project investment. But really, the main people doing this revolution today are the independent, meaning private companies, sometimes not even listed, which belong to bank or to private investors, which are launching huge amount of projects. And they represent 60% of the investment. I would say the profile is quite easy. They have, let's say, under license, access to the technology to develop those projects, and they are the one closing the financing to be able to benefit from it as soon as they will start the production and the market will be growing. Their way to do the project is quite simple. They go fast track, meaning that they try to go as fast as they can, and they don't really look on the price of the project. The idea is really to start production as soon as they can, because they know they have a value into producing clean hydrogen, and they will be able to sell it at any price. As simple as this. Now, if we look on, let's say, a bigger outlook, what is the market and where we are standing today, I think there are 2 dates which are quite important. The first one is a 10-year outlook, because that will give us, let's say, the perspective and the dynamic that we are going to experience as of today to go to the target of 2030. And another outlook which is more long-term, which is 2050. Because as you may know, many of the energy transition plans have, let's say, a deadline at 2050. So we know that we have to be more or less at this final stage at this time of the world. So if we look at the roadmap development, that okay, it's a mix of worldwide development, because if we focus, for example, on Europe, US, and in some Asian country, of course, the roadmap is more concentrated, and the revolution to hydrogen should be done earlier. But on a global scale, if we look at what the roadmap should be, it's more or less those parameters. The idea really on the next 5 years is to convert all those gray plants to blue plants by adding all those carbon capture on the first, let's say, period in all Europe and all the developed country, but then to later on do it on all the project worldwide. And the application will be the easier one, let's say, for transportation, to go after trucks, after bus, after ships, and of course public transport, because with few, for example, aspect of the value chain. For example, for all those transportation, you only need few stations to be able to supply them. So of course, it will be quite easy to be put in place compared to, let's say, domestic vehicles, where you would have to build a huge amount of refueling hydrogen fuel station, which is not on a 5-year period possible. So the first, let's say, application is really heavy transportation, because that's the most easy to do. Then on the following 5 years, so 25 to 30, here the idea will be to ramp up those blue capacities, but to also start to have a green production of hydrogen, which will be sustained and will be at the size, let's say, to benchmark the blue. meaning that you are able to build a supply chain, you are able to provide efficient green production for application in the industry and stuff like that. Here, the application will grow a little bit from the EV transportation. The first one will be to use hydrogen as energy storage. Of course, as you may know, electricity is not quite easily stored, and the renewable electricity are even harder to conduct and to drive to produce electricity when you need it. So hydrogen would be used as an energy storage to be able to be produced when we have wind and when we have sun, and to be converted to hydrogen and would be converted back to electricity when it's needed, meaning at night when everybody is going home and trying to cook. So this energy storage will be one of the biggest application for hydrogen tomorrow, and we'll see more detail the figure later on. So two other applications we'll have in the next 10 years will be to blend hydrogen with gas. In many applications of heating, meaning domestic gas that we have as a person in our houses, in the cities, but also that steel factory and cement factory have, you can blend on a proportion hydrogen with natural gas without having to change any infrastructure. The ratio today we have on the market is to say we have to replace 20% of the natural gas by hydrogen. And here the blend is quite, let's say, heavy enough not to benefit from any leak, and you keep a level of energy which is efficient enough not to have to change all your fire we have at home. So that would be one application that would be used, and of course the reduction of CO2 emission would be huge, because you can imagine if each natural gas application reduces carbon footprint by 20%, it's just a huge volume worldwide. And it could be done without real change of infrastructure again, which is really the important point. And the last application is, of course, those pilot industrial projects. As I was talking about steel plant, about cement plant, those are huge users of natural gas to burn, to produce heat. And of course, they are just producing huge amount of CO2 on an industrial scale. And of course, let's say they are the first target of any green environmentalist activist, because on one spot you could really make a difference on the volume of CO2 you are producing. So we'll see, and that's already the case in Europe and in some cases in USA, of projects which would like to run on green fuel for cement and steel factory. It's not easy to do because the process might be a bit different, but that's something that will be developed in the future, and we'll see pop up everywhere in the world. Then on the later period, until 2050, here the idea is to go full green and full blue from biogas. The idea is to use methanization and all the wasted or bio-wasted we may have to produce hydrogen. And here the application will be simple. The idea will be to convert all the oil and gas application which cannot be tackled via electricity directly to be replaced by hydrogen. And there the idea will be to go after all the power heavy industry, all the cement steel factory worldwide, and to convert all of them to reduce the carbon footprint of all industrial aspects in the world. Now, if we look at the grain demand, and if we try to put a figure behind it, if we look at the outlook on the end, let's say, of the scenario of zero carbon emission, where the world has succeeded in tackling the global warming, I would say, we would need to produce around 520 million tons of hydrogen a year. To give you a comparison, today the hydrogen production worldwide is around 90 million tons. So it means that we need to scale up this volume of production by more than 5, knowing that today all the production is mostly done via cracking natural gas, meaning gray, a solution we will not be able to use, of course, to be able to save our planet. So the idea behind is to say we need to convert our existing production method, but also to ramp up those capacities to be able to produce way more, because there will be way more application needed needing hydrogen to be tackled. If we look at the split, and again, I retake figures from IEA statistic and report, the idea would be to produce 310 million tons of hydrogen from green production and 210 million from blue hydrogen. Again, if we look at the figures, if we want to produce this volume of green hydrogen every year, we would require 3,600 gigawatt of electrolyzer capacity. It might not ring a bell directly, but just to give you an outlook, today we just have 300 megawatts. So you see the gap we have about the need, which is more than 3,000 gigawatt compared to 300 megawatt we have as of today. And to, of course, supply with clean electricity those electrolyzers, that would require 14,500 terawatt of clean electricity per year. And again, just to give you a scale about it, that's 20% of the production of electricity globally we have as of today. So it means that we just need to build up tons and tons of windmill farms and solar farms to be able to supply those electrolyzers, because there is no way we could supply those electrolyzers with the demand and the project we have as of right now. And again, we need to build this, let's say, over capacity of renewable electricity production, because the electricity used to produce hydrogen will not be used to, let's say, for electricity, for cars, for trucks and stuff like that. So all the clean applications that already need to be supplied firsthand. If we look at the trend and the dynamics of hydrogen production, here you have the timeline on the bottom, and here you have the volume. There is a huge, let's say, growing demand on the next 10 years. Year to year, there would be 60% growth. So it's just a huge volume of investment which are done every year. And after 2030, let's say the growth will slow down a little bit, of course, to go to maturity until 2050. But the average growth will be around 23%, which tell you about the market that is going to be built, which is just enormous, and will keep growing on at least the next 30 years. So that's why it's also quite interesting. Now, if you look at the demand breakdown in 30 years, of course, the biggest, let's say, vectors of demand for oil and gas will be the electricity. So that's what I was explaining. Electricity or hydrogen will be used to store electricity and to pass and to manage this, let's say, looping demand of electricity. But not only, you see that road transportation will ask about 90 million tons a year. Of course, all the chemical and petrochem activities will ask about the same volume. Same about ship transportation, because the idea will be to use either hydrogen or ammonia as a vector to build those motors and to clean the ship transport worldwide. And then, of course, you have other applications that might be a little bit smaller, but which are quite important as well, which are the steel application, the cement application. Here you see, I mean, the volume of hydrogen needed is just huge. And you have the last but not the least, the air transportation, which by itself will ask a lot of volume of hydrogen. Of course, that's the perspective in 30 years, because right now an hydrogen plane does not exist. So, of course, that will be a transfer, let's say, step by step. To the conclusion, I see the time is running, but I still have time, so that's great. The idea behind hydrogen is that you have to understand that it's a complete new market developing. There is nothing existing yet about hydrogen, and everything that is existing today will be either replaced or, let's say, abandoned, like all the great production technology, because the hydrogen of tomorrow is not the hydrogen of yesterday. And to do so and to develop this new market, you need not only the technology, but the supply chain, you need the distribution, you need the infrastructure, you need the technology. And those technology bricks are still in development. And that's why it's about the right time to enter this market. If you are thinking about it, it's because nobody has, for no one, a competitive advantage on those technology. And it's quite important for you, if you want to go after this business in the next years, to jump in right now, because today we are seeing and we are tracing with our two projects, Smart Explorer, all the pilot project and demonstrator project starting right now to go into the phase of front-end engineering. And if you want to be well placed and develop the technology and make the first references, you have to be today on those markets. Of course, the demand will be steadily growing until 2050, and there will be a huge volume of business at the end. And of course, in 10 years already, the hydrogen market will be comparable in size of project and volume exchange and commodities to natural gas. So that's really to give you an outlook about this market and how fast it will grow and how fast it can be a good opportunity for you to go after that. Of course, that's also a great opportunity for all the actors of the petroleum and oil and gas industry, because that's a close, let's say, stream of technology where you can transfer your know-how and have a competitive advantage to start to prepare your energy transition. And the last aspect, but which is not least, is of course the financing. As government are financing huge volume of money into those technologies, the financing is already closed and is secured on the long term, meaning that the contract will happen for sure. So the idea is really for you to jump in right now, and of course, based on our tool and our expertise, we'll be more than happy to do it. So we are coming to an end of the presentation. Now we are going to pass to the question of this webinar. Again, you can send me an email at guilhemjean@tobefirstconsulting.com to ask for the slide of the presentation.